Okay. Yep. We pick up with this. Today we want to do a very short introduction to, or I guess, end our applications piece. Then we want to do a short introduction to sine and cosine. YouTube Nation, I feel sick, so don't say my video sucks today. What? Anybody else want to tell me my video sucks? Anna, you want to mouth off? You don't want to embarrass me. All right, whatever. Okay, so speed is distance divided by time. That's what we talk about. But what about angular speed? So what if instead of counting the number of, like, say, feet or inches that we traveled per minute or second, what if we counted the number of degrees that went by? For example, a clock. If I look at the minute hand, how many degrees does the minute hand turn in 1 hour? 360 degrees in 1 hour, right? So that would be angular speed, okay? It travels that many degrees. We're not talking about distance, we're talking about number of degrees. So what we do is angular speed, you just use W. They actually use omega, but people get tired of writing it. Omega is a Greek letter for O. Omega is equal to theta divided by time, where theta is the number of radians, it's your angle. Just divide that by time. Are we okay with that? Linear speed, so we'll call it velocity because we could have, what's the difference between speed and velocity? Velocity is direction, so it can be positive or negative, okay? So velocity is going to be equal to, in this case, our distance, which we state is s, divided by t, which is time. You remember our lesson from a few days ago where we used the letter s. Length of an arc. And s was equal to r theta. So if you're trying to figure out what s is, you can take r times theta. S is the length of the arc, which is the same thing as r times theta. Now, can I do some magic here to give you an easier formula? T times W is equal to theta, right? So now if I take this and put it in for theta, what I get is velocity equals r times, instead of theta, what do I have? TW or T omega, however you want to say it, divided by T. The T's cancel, so velocity, instead of using that formula, which is sometimes tough for people to find, you could just simply take r and multiply by W or omega. So if you find your angular speed, then you can find the linear speed very quickly. Just take radius times your angular speed. Okay? So what you have here is 3 formulas. This one is separate. And then, you know, this one is really the same thing. Okay? They're the same thing. It's just the second one's easier to use for a lot of people. So we're just going to do an example where we use both of these. Bicycle wheel is 24 inches in diameter, rotates 100 rotations per minute. Find the angular speed and linear speed in seconds. So I want to find the angular speed. Angular speed is Omega is equal to r, I'm sorry, theta divided by t. So I asked this before, how many degrees does a minute hand turn in the course of 1 hour? In radians, how many does it turn in 1 hour? 2 pi. So we're going to use radians. 2 pi radians, okay? Now, if it rotates 100 times, then it hasn't gone around 2 pi, it's gone around 200 pi, right? So my angle is 200 pi divided by how many minutes pass by. This is rotations per minute. 1 minute, but we want it in seconds, so divide by 60 seconds. Somebody take 200, multiply by pi, and divide by 60. Yes, Miss Emily. I just stated that they'll over here they'll say in meters per second, so I just forgot to write that in the problem. Like here it says meters per second they want it, so does that make sense? Well, because it's rotations per single minute. So that's what RPM means, number of rotations per minute. Okay, and Quinn, you came up with a number? 10.47, and that's radians per second. Okay? And it says find the linear speed. Well, this is really easy because the linear speed, it says velocity is equal to r times omega. So what is my radius in this problem? 12 times my 10.47. 12 times 10.47, somebody. Well, 25.7, and that's what's my label? This is a rate. We're not doing miles, but you're right, miles per hour is the idea. Not RPM. What's our length? Inches per second. Yeah, there you go. Good. Any other questions with that? Yep. Yeah. Yeah. Yep. Yep. Okay, paddle wheel. What's a paddle wheel? It's like on a big boat. I got to go to prom my sophomore year. A junior girl asked me, and we had prom on a paddle boat. Yeah, it's cool. Had the dinner and the dance. It's fun. Tell you about it later. All right. So I want to figure out the speed of the current. So what's happening here is that you got this paddle boat or paddle wheel. It's got a radius of 0.3 meters. It rotates 80 rotations in a minute. Find the speed of the current. So is the actual paddle wheel moving at all? Okay, it's moving. Is it covering any distance? No, but is the water covering distance? Yeah, like if a bug falls in the water, it's like, how far does it travel downstream? So like, the river is actually moving along and it's turning that paddle wheel. So we want to find the speed of the current. So we know that velocity, again, is equal to r omega. Well, what's r? 0.3. Omega, we're going to use a formula. Omega is equal to theta divided by t. So theta is the number of radians turned. So 1 revolution is how many radians? 2 pi. How many rotations does this have in a minute? 80. So that's a total of 160 pi radians over the course of a minute. We want this in seconds, so I should divide by 60 seconds. So this is omega. Somebody come up with a number there for me, please, like 8 point something. 8.37 radians per second. So what we can do is put that in for omega. That's what omega is. We just solved for that. Multiply it by 8.37. And velocity is equal to what's 0.3 times 8.37? 2.5. What's our label? Meters per second. We did the conversion. How's that? Not too bad, huh? Simple little formula. I bring that up because of its applications of physics and other things. We won't really use it again in this class. Flip it over. We're just going to do this page. It's nice and short. Yep, book assignment today. Okay, I'm going to make this quick and short. I normally like to tell this story, but I took a graduate level course about the history of mathematics. I had to write a paper on the history of something. I chose to write it on the history of the sine function. It's really interesting. If you want to read it, I got it. It's about 12 pages long. It's a good time. Devin? Okay. Okay, all right. After I said sine, you kind of drifted off there. All right, got it. So let me just tell you the very brief history. The word sine means half of a chord. So a chord in geometry is something that stretches from one side of the circle to the other. And half of a chord, you say, well, that's the diameter. Not necessarily, because that's a chord too. So we're referring to half of the chord. And they would use these half chord measurements to apply trigonometry. Say, for example, find the distance from Earth to the sun. They would apply all these to really astronomy. And it was very advanced. In fact, you could go to ancient Babylon. You'll find like really big boulders where they've cut in there different tables of stuff. They'll have a table of sine values. So like, if your angle is this, then your sine value is this, so on and so forth. Some of the first mathematics, advanced mathematics done at that time. Well, what happened was when the Romans took over, you guys know about the Roman Empire, right? Okay, so when they took over, they took over the whole world. They just stopped doing mathematics. They were dumb. They they just did like philosophy, boring stuff. So mathematics kind of got lost for a while, but the Arabs caught up with it, and they had a different name for this sine function. And then finally, when universities came around, they would translate the stuff into Latin. They took the word for half chord, which is what we're talking about, half chord, and they mistranslated it. They used a Latin word that starts with an S, ends with an S, and is 5 letters long. Anybody want to guess what it is? It has to do with why I'm sick. Sinus, yeah. Sinus. Mistranslated to sinus. So the word sine, you wonder where it comes from. It was supposed to mean half chord. That mistranslated means your nasal passages. That's the story. So sine literally means half of a chord. So if you would think about kind of this stretch here where you got half of a chord, they would then attach, say, a triangle to it. They would say, well, that's the opposite side of the angle. So we think of it as opposite. They thought as half of the chord. Okay, doesn't really matter. The point is that sine is the opposite side divided by the hypotenuse. Okay. You may say, why is it that way? It's defined to be that way. We've defined it that way. Okay. We're stating a definition right now. This is what it is. Kind of like in geometry, when somebody said, what's an angle bisector? You're like, well, that divides an angle in half. Somebody said, well, why? Well, that's its definition. It's what it does. Now, I want to make this clear. If you're in the unit circle and you draw an angle, okay, like that, and you have your radius, and you have your x value and your y value, you can see that sine is going to be, if you call this the opposite divided by the hypotenuse, it's the same thing as the y value divided by the r value. And so that's how we're going to talk about sine. And when I first learned it, I never thought about SOHCAHTOA. SOHCAHTOA, you guys have heard that before? I've never heard it. Never heard it until I started teaching. So what is SOHCAHTOA? They're like, well, that's how I do trigonometry. I was like, well, I know trig. They're like, you don't know trig if you don't know SOHCAHTOA. I said, sure, sine is y over r. Like, what? Y over r? I said, yeah, sine is y over r. Take it back to unit circle. They're like, whoa, well, I just think of SOHCAHTOA. So I think of y over r. What's the radius in the unit circle? So therefore, y divided by 1 is y. So you can see that it's just the y value of your terminal points. It's very easy. Cosine is your adjacent side, ADJ divided by HYP. See, that stuff's confusing. You get x divided by r. It's your x value divided by your radius. And in a unit circle, if the radius is 1, then the cosine value is just x. Tangent, opposite divided by adjacent. What's the opposite side? Y, and the adjacent side is x. So we define it to be y over x. Now think for just a second. Connection. Y over x. Slope, right? Rise over run. Yeah. Tangent, slope. Okay. Now, this is literally spelled cosecant. All right? But we write CSC. Last year the question came up, do we have to say sine or can we say sin? You have to say sine. Yeah. It's not that hard. And people say, well, it looks like sin. I know it does. I know. But that's just goofy. It's sine. Just say it. They say I can't remember that. Well, then maybe you should be in this class. You can think of sine. It's not that hard, right? Sine. This is cosecant. Cosecant. And cosecant is simply the reciprocal of sine. It is the hypotenuse divided by the opposite, or r over y, or 1 over y. That's what cosecant is. It's the reciprocal. You just flip it upside down. Secant is the reciprocal of cosine. Secant is the reciprocal of cosine. So hypotenuse divided by adjacent, which is r over x, which is 1 over x. Some people look at the last one and say cot. It's not cot. It's not cot. Cotangent. Cotangent. Cotangent is the adjacent divided by the opposite, or x over y. And we've got more stuff to add to that. That's just the basics. So we're going to do these 3 problems and call it a day, okay? Change this one to cosine. We're going to cosine of, we're going to do negative 7 pi over 6. All right, so it says, draw a special triangle, picture and use special triangle to calculate the exact value of the following trigonometric functions. So, for example, when I see sine of pi over 3, I automatically think of the square root of 2, square root of 3 over 2. That's what happens if Luke gets a hold of your computers. Take out your calculator. Those are ribeye states. So go into mode, and are you at radians or degrees? Okay, move it over to radians. Just enter on radians. And then watch what happens here, okay? I look at the sine of pi over 3, and I say it's the square root of 3 over 2. Take the sine of pi divided by 3. And look at what you get. Now if I type in the square root of 3, parenthesis, and divide it by 2, I get the same thing. So the question is, how did I know it was the square root of 3 over 2? Well, same thing as we did last week. We did a worksheet on terminal points. We do the same thing. That's the majority of what you're going to practice today. I need you to be really good at this. Really good at this, okay? Pi over 3 is how many degrees? 60. So if I draw unit circle and I go 60 degrees, what kind of triangle do I have? 30, 60, 90. The radius is always 1 in the unit circle. What's the shortest side? A half. How do I get the longer side? Multiply by root of 3. And I get root of 3 over 2. So that has a terminal point. It has a terminal point. What is the coordinate? What's the x value? 1/2. And the y value? Very good. Because pi over 3 converts to 60 degrees. Right? We'll have a quiz on that probably Thursday or Friday then. This week we'll quiz on your conversions. Yep, just a little quiz. So, watch what I do. I'll do all 3 of them. Sine is equal to the x value, or the y value, of the terminal point. Look at that. From notes we just took, it says sine is y. Y divided by r. Well, r is just 1, isn't it? So I've got square root of 3 over 2. Sine of theta is equal to your y value. This terminal point is an x value and a y value. So cosine of pi over 3, what would that be? 1/2. How do I get tangent? I take the y value and divide it by the x value. So square root of 3 over 2 divided by 1/2. So dividing by 1/2, I'll multiply by 2 over 1, and I get square root of 3. And that's exact. Square root of 3 is like 1.73, right? So you take the tangent of pi, divide by 3, we'll get 1.73. There you go. Exact. That's how we come up with that. What do you think? So today you're going to practice drawing more circles and then just identifying what sine, cosine, and tangent are. Now, in your assignment, they're not going to say find all 3. They'll just say find sine or cosine or tangent, okay? That's all they'll do. So I'm just doing all 3 so we get extra practice. So negative 7 pi over 6. You tell me, where's that located? Where do I go? Which quadrant? How many degrees is that? Negative 210. Excellent. Emily's on the ball. So we've got, like that. Okay. That's the rotation in the opposite direction. So I've got 90-degree angle here. What's this angle right here? What? 30. Yeah, because you're 30 degrees past 180 for 210. Very good. So I want to find this terminal point there, and then I can list sine, cosine, and tangent. So the radius in the unit circle is 1. And then what's this short side here going to be? 1/2. And then what's this long side going to be? Square root of 3 over 2. So the sine of negative 7 pi over 6 is equal to the y value. Let's write our coordinate. What's the coordinate? Negative root of 3 over 2, right? Because it's in the opposite direction. And what's the y value? 1/2. So sine's going to be, is sine the x value or the y value? Y value. So sine is 1/2. Cosine of negative 7 pi over 6 is what? Yep, negative root of 3 over 2. And tangent of negative 7 pi over 6. How would I do that? y divided by x. So 1 over 2 divided by negative root of 3 over 2. You got to divide those. Instead of dividing, multiply by the 1/2 times negative 2 over the root of 3. You can see those cancel. I get negative 1 over the root of 3. How do you simplify negative 1 over the root of 3? Yeah, multiply by the root of 3, you get negative root of 3 over 3. And that's what tangent is. Okay. This one goes quick. 7 pi over 4. What's that? Degrees. 315. Very good. Yep. So what kind of angle do I have? 45. Radius is 1. Remember what the sides are? Root of 2 over 2. So what's that coordinate? What's that location? 2 over 2 and negative root of 2 over 2. So what's the sine of 7 pi over 4? Negative root of 2 over 2. What's the cosine of 7 pi over 4? Root of 2 over 2. What's tangent? Close. Not 1, but negative 1. So you got negative divided by positive. Give me one more. Tangent of pi over 2. This one's super easy. What's the terminal point for pi over 2? Pi over 2 is 90 degrees, right? So what's that terminal point? What's the coordinate? 0, 1. So the sine of pi over 2 would be 1. The cosine of pi over 2 would be 0, and the tangent of pi over 2 would be undefined. Because you have your y value divided by your x value for tangent. So 1 divided by 0 is undefined. Okay? So you don't always get crazy numbers. Sometimes you get numbers like that. So, all right, here we go. This is from 6-1, what we finished up. There's 3 problems just like what we did. 682. And then 5.2 I've got some. These are all problems like we just did where it says find the sine of pi over 3 and you draw the triangle. I've increased the problems this year because in previous years it doesn't seem like students could do this past the first day. Like we practice it once and then it's gone. And people just have referenced a sheet of notes that I give them. I'm not giving you the sheet of notes yet. And I don't want you to just go on your notes and look at pi over 3. I want you to draw the triangle. You need to think of it up inside your brain. Just like you think of the number line or a thermometer when you're adding and subtracting. You got to be able to think of the unit circle when you're doing these conversions. Otherwise, it's just simply short-term memory that will go away. And then you'll just get frustrated calculus teachers later on. They'll say, why don't you remember your trig? You'll say, because I had a bad pre-calculus teacher. So I'll be a good pre-calculus teacher and give you more problems, okay? And you got 10 minutes to work on right now. I'm not feeling well. It's very possible I might not be here tomorrow. And I promise I won't be here on Wednesday. I have a conference to go to. So, yep. My guess is one of those days you guys will end up with a work day. So we'll see which one. That's my guess.